Hi, ladies and gentlemen. Welcome to my YouTube channel. This is Sichamba Jacob. So we are doing change of variable to integrate this one. Okay. So there are so many methods that you can use. One of the methods will just be to do the direct one where you let this be equal to u and you integrate. You just differentiate what is inside. You integrate just like that. But in this video, I'm going to show you on how to use change of variables. So change of variables, the first thing must be to say u is equal to x power 2 plus a 1. So you just get what is inside here. The next thing here will be to change now, make x subject of the formula. So how will this look like? It will be u minus 1 is equal to x power 2. To make x subject of the formula, we are going to square root both sides so that we get rid of this power. So it will look like this. This is what we have right here. So I've made x subject of the formula. Okay, so let's keep this data nicely. We're going to write it here. Our u is x power, our u is equal to x power 2 plus 1, and our x is equal to root over u minus 1. This is what we have. We're going to keep this data. It's very important right here. So let's erase here. We've done two steps here. First step is to identify our u from here. The next step is to make x subject of the formula. Now the third step will be to find the du. We're going to say dx du. We are expecting u in this case, so to find the derivative of this, we will say dx du, which is equal to 1 over 2 root over u minus 1. So this is a derivative right here. Maybe the question may be, how if I managed to find this derivative? So now let me put it here. Let me put it here so that I show you on how I got it. So this is our dx du, which is 1 over 2 and the root of what? Of u minus 1. So now how I managed to get this one? Let's use the different marker so that you understand. I just got my x, which is right here, and I changed it to this, of which this root you're able to see is the same as the power 1 over 2. So you must know this. Let me write it properly. So x is equal to u minus 1 and the power there 1 over 2. Okay. So now once you do this, you say dx over du, which will be, you get this power multiplied by the coefficient that is in front here. In this case, there is a 1. So it will be like this. And this like that. To the power here, subtract a 1. So when you subtract a 1, because we know 1 over 2 minus a 1, it will just give us a negative 1 over 2. And this is what we have now, like this. Okay? The next thing here will be to find the derivative of what is inside here and write it here. In this case, it's to just be a 1. Okay? So once you do this, you simplify, you shall get your answer to be like this. Now, what do laws of indices say when you have got a negative power? The laws of indices here say that you drop it, okay? So it will be dropped. it will look like this. This is how it will be, okay? So it will just come down here. Now, since you are multiplying here, this whole thing will just be like this. Okay, this is how it will look like. Okay, this is power 1 over 2. Now, what did I say when you've got a power 1 over 2? What does it mean? It's the same as the square root. So this is how I got up to this stage. Okay. So now let's now try to move on and check some other things that we need to do. We are at step 3 where we've managed to find the derivative. Okay. So now our step 4 will be to now change the limits. This one and this one. We have changed for this one, it's right here. For this one, it's right here. For this one, it's actually here. Though we have not finished, it's just now to make it dx subject of the formula, whereby we just cross multiply. So it will look like this. So this is what we have, and it's what we're going to substitute right here. So now for the limits, we know that this is x is equal to 1 and x is equal to 0. So the upper limit, x is equal to 1. The lower limit is x is equal to 0. So now we substitute. Where are we able to see x? It's right here or even here. So let's just move with this one. So we're going to substitute a 1 here. So when you substitute a 1, we put a 1 here. We shall have 1 plus, actually 1 squared plus 1, which will just give us a 2. Meaning our upper limit is changed to a 2. For a lower limit, we substitute a 0 right here. We solve, we shall get a 1. So upper limit is 2, lower limit is a 1. Okay, so now let's now plug things back. So we shall have the integral. The upper limit we know it's a 2 and the lower limit is a 1. For the x here, we shall put this. We are changing, okay, x from here. And then we shall have a u, because we know that this is a u. U is what is here. So we shall substitute a u and the power 3 there. For dx, we have dx right here. So it will be du over root over 2 and the root of what? And the root of u minus 1. So this is what we have. Okay. So now here we know that this and this can cancel or will cancel. So we shall remain with the integral limits from 1 to 2 and the u there, power 3 over a 2 and the du. Okay. So the next thing here will just be to integrate, where we shall get a 4 over 8. You add the 1 here, you shall get a 4. You divide, so it will come here. So here plus 1, here it will be here 4. So 2 times 4, it's 8. And this is how I've reached this point. So here we shall get a 1 and a 2, these limits. So when you plug in the limits, you are going to get a 15 over 8. And this is our solution, 15 over 8. So maybe you may be asking that, how have I found this? So your duty here now is just to substitute a 2 here. So you shall have a 2 right here, power 4 over 8 minus a 1 now, 1 power 4 minus 8. And when you simplify this, it will give you, or it will take you to this solution. Thank you so much for watching. Remember to subscribe to my YouTube channel. This has been Sichamba Jacob. Bye-bye.